Hello everyone, welcome back to the channel. So today we will be doing this post contest discussion for the recent Codeforces round 996, which was rated for Division 2. Yes, and without further ado, let's get started. So problem number 1, that's A, two frogs. And I have I have mentioned the timestamps in the description for those of you who want to skip the solution for A, B, not C. Okay, so if you want to skip C, then skip the video, right? So, yes, and there are n lily pads arranged in a row, numbered from 1 to n, left to right, and Alice and Bob are frogs initially positioned on the distinct lily pads A and B. Okay, so yes, for those of you who do not want problem intro as well, there are timestamps for that too. So problem intro, solution, and the code walkthrough. You can go along with that. Okay. So they take turns jumping, starting with Alice. During a frog's turn, it can jump either one space to the left or one space to the right, as long as the destination lily pad exists. For example, on Alice's first turn, she can jump to either lily pad, the previous one, or the next one. So, provided these lily pads are within bounds. So, it is important to note that each frog must jump during its turn and cannot skip its own turn. However, there are some restrictions. The two frogs cannot occupy the same lily pad, and if a frog cannot make a valid jump on its turn, it loses the game. As a result, the other frog wins. Okay, so uh, we want to calculate if Alice can win guaranteedly. Okay, so guaranteedly, and if Alice can win, then we have to output yes, and if Alice cannot, we have to output no. So constraints are pretty less, but anyways, they are not going to help us. I think they are just less for system testing to be easy. And yes, let us take a look uh, to, towards the first question. So, when will Alice win or lose? Okay, suppose if Alice wins, okay, okay, without loss of generality, suppose any one guy wins. So Alice wins or Bob wins. So if Alice wins, so suppose these are the lily pads. Suppose this is one player and here is the another player. Okay. So what I can notice is that this player will win, right? Because for the next turn, okay, wait. So the player which is here, suppose it is his turn or her turn. Okay, so notice that this player cannot make a move, right? So suppose if this is Alice and this is Bob, and if she is trapped in the corner and it is Alice's move, she won't be able to move. Okay, and in contrast, if it's Bob's move, so Bob doesn't have any option and he will jump here, then Alice will jump here, then in next turn Bob will jump. Okay, so Bob will jump here and Alice will jump here, and this process will go on until Bob jumps here and Alice jumps here, and there are no further lily pads left for Bob to hop on. Okay, so in that case Bob loses, but if it's Alice's turn, Alice wins. So how can I generalize this case? It is pretty simple, right? So firstly, we know that it's Alice's turn and separation between the two. So if separation here was 1 and if it was Alice's turn, she lost. But what if separation was 2 or even? You can say Alice and suppose Bob here. So Alice is at first lily pad and Bob is at third lily pad, and separation is 2. So in the Alice's turn, she will jump here. Okay, now our condition, now our state of the problem is like this, and it is Bob's turn. So Bob will keep getting cornered. So Bob will jump here, Alice will jump here, Bob will jump here, then Alice will jump here, till the Bob has no moves left to do. Till then game will continue. So what I can notice is that, so the absolute difference between the position of Alice and the Bob, if it is not divisible by 2, then Alice cannot win. No, Alice won't win. So we have seen that here, right? So here, in the first case, B was 2 and A was 1, and Alice was unable to win. And if it is equal to 0, then Alice will definitely win. That is basically the small and clean solution for the first problem. So code is pretty simple to follow. There's nothing in code, just taking the input and one if else statement. Okay, so let us take a look at the second problem. Okay, so, so they change the statement uh, to this thing. So basically they change the statement for uh, suppose some guy or whatever it is, so has raised objection that the AI cannot go negative. Okay, so that is basically the common sense, I would say. Or if you want to be rigorous, then yes, definitely you have to include this statement, and I think it's better to include it. I myself got somehow confused in here, and okay, no problem. So again, there are timestamps in the description. You can directly head to the solution if you have tried to solve the question on your own and haven't able to, weren't able to. And yes, there are n different types of magical materials numbered from 1 to n. Initially, you have AI units of materials I for each 1 to n. Okay, so basically, you have some magic materials and you have some quantity of that for each index. Now, you are allowed to perform the following operation. So, select a material I where I is basically the index, and then spend 1 unit of every other material j, in other words j not equal to I, to gain 1 unit material of I. More formally, after selecting material I, update array as follows. So so element at the ith index will be increased by 1, and every other index there will be a decrement of 1 which will be performed. And yes, that is basically the operation doing. And you cannot spend resources you do not have. Okay, so basically if at any point AI becomes 0, you have to perform the operation on that ith index to increase that. Okay, you cannot operate on some other index and use some 1 unit of that magic which is already 0 to increment some other magic. Okay, you cannot do that. And you are trying to craft an artifact using these materials. To successfully craft the artifact, you must have at least bi units of material I. For each I from 1 to n, determine if it is possible to craft the artifact. Okay, and by performing the operation any number of times including 0 as well. Okay, so let us take a look at this sample test case. So in here, first sample test case, I want to take a look at this part of the screen. And yes, if I increment this, if I perform the operation on this first index, it will get converted to 1, and all the other elements at other indices will get reduced by 1. So 5 will become 4, 5 will become 4, and this 1 will become 0. So that is basically the array B, and we are good to go. So in that case, answer will be yes. In the second test case, if you try to increase this thing first index, then this value drops, right? And if you want to increase this value drops. Okay, so that is basically the crux of the solution. So I will explain it in further detail. Okay, where's my pointer? Okay, wait. Yes, right there. And a solution for the second problem. Okay, so suppose some at consider two indices bi and bj, ai and aj. Suppose at these indices ai is less than bi, so you want more of this material. Uh, so you want more of this material to craft an artifact, and more of 8jth material as well. Okay, so basically it is mandatory that you want to perform what you can say bi, at least bi minus ai operation on this ith index, right? And at least bj minus aj operations on this index. Okay, and what I can notice here is that suppose I try incrementing AI first without loss of generality. I try incrementing AI first. And then what will happen to AJ? It will decrease by the same amount, right? Okay, it will decrease by same amount. And if I try to increase AJ, AI will decrease by the same amount. Okay, what amount you have incremented J, okay, AJ. So that is basically the thing. So if these are the values of AI and AJ, so let us take a look at it pictorially. So suppose this is the value of bi, this is the value of bj, this is the y-axis you can say, and here suppose this is the value of bi, this is the value of bj. Here this, okay, one bar is fine. So suppose this is the value of ai and this is the value of aj. Okay, so when you try to take this value ai till this here, so AI will become something like this, but you have to decrement this AJ by the same distance, by the distance this much, right? So if your state is something like this and you have decremented the AJ somewhat, okay, you have decremented the AJ somehow, somewhat, and now you want to increase this AJ to BJ, right? You want to bridge this gap. Okay, then if you try to do perform operations on the jth index, value at the ith index will decrease. So these two are basically nullifying the effect of each other, right? So what I can notice is that if there are two indices for which my ai is less than bi and aj is less than bj, two indices are greater than or equal to two indices, my answer is going to be no, because they are nullifying the effect of each other, right? Okay, so that is the thing. And what if you have zero such indices such that ai is less than bi? Then we are good to go. Our answer will be yes, right? Okay, that's degenerated yes, but our answer is going to be yes. And what about one such index such that ai is less than bi? So listen, okay, so there will be only one such index such that AI is less than BI. Okay, so suppose this is some value BJ and this is AJ. So I will perform operation only on that ith index, right? I will perform operation only on that ith index. So to bridge this gap right here, take a look at the green mm, blue pen. Okay, so I want to clear this gap. Okay, so suppose the difference between this AJ and BJ. So AJ minus BJ is suppose difference. Okay, diff. And what I will do is that I will calculate minimum of all these differences over all J. For all J, I will calculate the minimum difference. So minimum difference. So suppose this is the minimum difference. And when I try to perform the operations on the ith index, the value or the what you can say, the amount of magic for every other index will decrease by bi minus ai, right? Correct? Yes, it is correct. But if that bi minus ai is greater than difference, so if this bi minus ai is greater than difference, then you will satisfy the criteria for the ith index, but you will decrease this aj down further of bj, so you won't be satisfying the criteria for bj then. Okay, so that is the problem. And if there is only one index such that ai is less than bi, you want to just check this condition. if my difference if my difference, okay, if my difference is greater than or equal to bi minus ai. Okay, so this basically this difference is basically minimum of all the differences for all the j which is not equal to I. Okay, makes sense. I hope it does perfectly. And yes, let's head towards the code. Code is pretty simple to follow. Let's take a look. Okay, and yes, I have recently noted that the submissions on some number of submissions on the Codeforces has passed 300 million, isn't it? Yes, it has. I wonder who made the first submission on the Codeforces. Okay, anyways, time. It's not the right time to find it out. We will find it some other another time. Okay. Yes, code is pretty simple to follow. Taking the input and checking how many indices are there such that AI is less than BI. If there are zero, our answer is basically yes. If there are greater than or equal to 2, our answer is no, because basically the two indices will nullify the effect of each other. And yes, and if C is equal to 1, this is basically the code explained in the algorithm, right? So this needed is basically the what is needed to bridge the gap between that index I and this mini is the difference, nothing more than that to ponder over this code. So I hope you understood it. Okay, let's head towards the problem C. Okay, I don't know about the others, but I found this problem pretty, what you can say, pretty amazing or something like that. I haven't checked the editorial yet. I wasn't able to solve this problem on my own in the contest. But anyways, let us take a look at the solution. I was able to come up with the solution after the contest. Okay, I think it's the pretty pretty nice solution that I have come up with. So let's take a look. Again, there are timestamps in the description. You can directly go to the solution part. So in the wilderness lies a region of mountainous terrain represented as a rectangular grid with n rows and m columns. Each cell in the grid is identified by its position I, j, where I is the row index and j is the column index. And the altitude of cell ij is denoted by aij. However, this region has been tampered with. Oh, sad. A path consisting of n plus m minus 1 cells starting from top left corner 1 comma 1 and ending at the bottom right corner n comma m has been cleared. Okay, so for every cell I comma j along this path, the altitude aij has been set to 0. Okay, so the path moves strictly via downwards and the rightwards steps. So after looking at this number n plus n minus 1, it is pretty obvious that path should only move downwards and rightwards. Okay, okay. So to restore the terrain or whatever it is called to its original state, it is known that the region possessed a magical property. Oh, magical property before it was tampered with. Okay, all rows and columns share the same sum of the altitudes. Interesting. More formally, formally, okay, you have understood the sum of the elements in the every row and the every column is basically the same, are same to some value. Okay, so our task is to assign new altitudes to the cells on the path such that the above magical property is restored. It can be proven that a solution always exists if there are multiple solutions that satisfy the property. Any one of them may be provided. Okay, so the constraints are up to n and up m, both are up to 10 to the power of 3. So basically we can devise the O of n into m solution. Okay, so D, R, R and D is basically the sequence of steps that we have taken in this first test case, and N and string is provided, and yes, the terrain is provided after the road is cleared. Yes, so let us take a look at the solution. Okay, so I had a sip of water and recollected the solution for the problem C. Okay, so here we go. So the problem number 3. So let us take a look at some sample test case to understand what's happening. Okay. Oh, yes, looks fine. Oh. Yes, so this is our input where n is equal to 3 and m is equal to 3. Basically, we have the 3 cross 3 grid at our disposal. And yes, so our path follows like this. Let me change the color. So down, right, then right, and then down. Okay, so suppose how will I come up with the solution? Okay, so what will I do is that suppose at this first square I will suppose there was x. Okay, so x 2 3 0 0 0 3 1 and 0. Okay, so if there is x here, what will be present here? So right here, what will be here? So here sum of the first row is x plus 5, and which is basically the sum that every column and every row should possess. Okay, so here it should be 2. Okay, and what about this thing? So right here it should be something x plus 2, right? So yes, let us replace it with x plus 2, right? What about this? So it should be basically 1, right? Okay, and what about this? It should also be 1. Okay, sorry, so that is not 1, it is x plus 1, isn't it? So we want to preserve the sum 3 plus 1 plus 1 5 and x as it is. Okay, so what I can notice is that I have come down till here, till the cell n comma m, by satisfying all the constraints for the cell 1 comma 1, this cell, for basically for every cell on its path I have verified that it is correct. Okay, it is correct. So the only thing I want to verify here is that, take a look, this is the most critical thing in the solution. So only part I want to check is that I want to check if this part and this part both are in according to each other or not. So basically sum of this row and this column should be x plus 5. Here trivially in this case it is x plus 5. So basically here my x can take any value and it will satisfy the constraint in the problem. So basically that's the thing. Okay, I can take x as anything and update my matrix accordingly and get to the solution. Okay, so let us take a look at another test case. Okay, this test case is nice. I want you to focus on this test case. Okay, big enough. And okay, so here in this case, so okay, let's take a look at this sample test case first, and then we will try to build our solution, general solution for every test case. Okay, so right here I will assume that at position 1 comma x, 1 comma 1 there was x. Here 1 0 2 3 0 0 0 0 0 minus 1. Okay, wait. Yes, yes. So I've drawn the grid and our path is like down, right, 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 down. Okay, this is basically path, then down and then down. Okay, so our path is like come here, like this, like this, like this, like this. Okay, okay, cool. And at 1 comma 1 I am assuming x was there. Okay, so my sum for every row and every column is fixed now, which will be x plus 6. Okay, right. Let me zoom a little bit. We need to zoom actually. So yes, this is the bigger picture, and sum is x plus x for the every row and the every column. So what should go here at this index? What should go here? So it should be something like, so let me erase all these things. Okay, so here it should be x is already there and minus 1, so here it should be 7. Okay, Yes. So what should be here? So it should be x plus 5, right? So basically looking at this column. Okay. So there is one clever trick used in the solution. So if your path goes right, so if your path goes right, you will check the column. Okay, if your path is going right, to obtain the information about the this value which we have to fill, we will consider the column sum. This is the most important part in the solution. So take a look, and if we are going down, okay, down is like this. If we are going down, suppose we were going down, right? So suppose this is the row and this is another row, and you have suppose until here, okay, till here, and you want to go down, okay, and now you want to fill the value here. So if you want to go down, you will check this row sum because all the other values are already computed, right? So that is clever trick used in the solution. Okay, anyways, we'll proceed further. Yes, so here it will be x plus 5. What about this thing? So here it should be x plus 9. Here it should be x plus 8, I guess. Not guess. I have calculated. Anyways, so x plus 8. What about this thing? So now from this guy we are going down. Okay, so we won't check the column sum for that, right? We will check the row sum as explained some moments ago. So here we will need minus 2x minus 2x minus, so the sum of the elements is like 3x 3x plus 5 plus 7 12 plus 8 20 and 9 29. So it will be minus 2x minus 23. So this is why we need to zoom in a little bit. Okay, so what about this thing? So it should be x plus 13. Okay, what pen am I using? X plus 13, isn't it? So yes, 13 minus 3 is 10, minus 3 is 7, minus 1 is 6, and x is as it is. So when I come to here, so here what I can notice is that, so I'm going down. Okay, I'm going down, so I will check the row sum as explained some moments ago. So by considering this row sum, okay, by considering this row sum, I will put x uh, plus 7, right? So is it okay if I put x plus 7? Yes, it satisfies that the row, it satisfies the condition for this row. Okay, so one thing that we have done somewhat wrong in respect to this column. So take a look. So of when we updated this and this thing, we were going according to every row and column, but when we came to this last cell in the grid, okay, when we came to the last cell in the grid, we just incremented its value, or what you can say, we just assigned its value base on the basis of only row, not the column, right? So we haven't considered anything about this column yet. So we need to be consistent for this column as well, right? So let's be consistent for that column. Okay. So basically we need to solve this equation involving one variable, which is x, right? So the sum, which is x plus 6, should be equal to minus 2x plus x, and plus x will be 0, plus 13 plus 7 is 20, 20 plus 3 is, okay, wait a second. So yes, 30 plus 7 is 20, plus 3 is 23, minus 23 is 0. So from here I get that x is equal to minus 6, and I will just plug in x is equal to minus 6 in all of these values to get my final grid, and which will be my answer. So pretty cool. Yes, and how to code it up? So let us take a look. So one more thing. So let me explain one special case as well. So special case was this thing, I guess. Yes. Okay, so let me again write the grid. Okay, so here's the grid. Okay, I thought I paused the video while drawing the grid, but it seems I didn't. Okay, anyways. Okay, so basically we will assign 1 comma 1 as x, and our this row sum is basically here x plus 47, right? Okay, so what will be, okay, let us calculate the sum of these guys, and accordingly calculate the values here. Okay, so 20 plus 6 is 26, and 39 and 22, so it will basically be 61, right? So 61, is it correct? Yes, so 13 plus 6 is 19, and 1 less than 20, and this is 2 more than 20, so I guess it's correct. What about this thing? 41, 42, and 50. Guess I'm correct. 41, 42, and 50. Yes. Here 13 and 12 25 and 1944. So yes, here it will be x minus 14. Here it will be x minus 3. Here it will be x minus, okay, not x minus, here it will be x plus 3. Okay, and here, so when I leave this cell, okay, when I leave this cell, I am going right. Okay, I am going right. So to update this cell, I want to consider the column sum. Okay, so that is basically what I explained few moments ago. So column sum here is 4x minus 4x minus 14, right? So 4x minus 14, and here it should be minus 3x plus, what you can see, minus 3x plus 61, right? Okay, and let me erase these guys as well. So now it's time to calculate the column sums. So for this column, it is basically 31 plus 17 is 48, and okay, wait, 25 plus 20 is 45 plus 6 is 51. So it is 51. Here it is 15, 49. 49, yes. Here it is 44, isn't it? So 13 plus 9 is 22 plus 20. Here it is 30. Okay, wait. 27 plus 11 is 38 and 22 is 60. Okay, so here it will be minus x. So taking a look at this column sum, okay, because we are going right from this cell, then we will take a look at the column. Okay, so it will be minus x minus 4, right? So if you add 51 to this, okay, why minus? Not minus, only plus. So x minus 4 plus 51 will be x plus 47. Here it should be x minus 2. Here it should be x plus 3. And here it should be x minus 13, right? Okay, we are good to go. So for this value calculation, you came uh, right, you came by right path. Okay, so by following the right direction to the last index. So basically you satisfied this column, but what about this row? Did you satisfy it? Okay, let's check. So it is basically the, okay, this sum is basically for this row, last row, it is x. So this is 57, 55, 58 and minus 13. Okay, am I missing something? Okay, not I'm not missing something. So basically it is x plus 44. Okay, so now you claim that x plus 44 is equal to x plus 47. So basically that is our desired sum, right? So will it ever happen? Will it ever happen? No, right? It will never happen. So this is the edge case in the solution. Okay, so this will never happen, right? So this is the edge case in the solution. In this case, you can notice that any x would suffice. Okay, I think so. Wait, let me check. Let me check again. Yes, so any x would suffice in this case. So this is basically the edge case, okay? Edge case. Then you have to take the care of this edge case, okay? So when does this edge case appear? So we will take a look at that in the code. Okay, okay, so this is basically the edge case and other what you can say other test cases I have explained pretty well, I think. So let us head towards the code. So my code has many debugging statements. So this code has many debugging statements. So let us take a look at the clean code. Okay, so code is slightly larger for my logic, so bear with me. I will explain it to you, I believe. Yes. So taking the input n comma m, taking the input of string, and taking the input of the matrix, and this is pretty nice way to convert the, what you can say, convert a string to the one based indexing. And what this dummy will do is that, what this dummy vector will do is that, so not vector, so array, multidimensional array, it will store how many multiples of x are present at that cell. Okay, makes sense. So for the cell 1 comma 1 in this grid, 1 comma 1, dummy of 1 comma 1 will store 1, right? So because it has one multiple of x, this cell will also store 1, so will this one and this one as well. So but dummy of, okay, dummy of, okay, why isn't this not disappearing? Dummy of, what you can say, 5 comma 1 will be minus 3. Okay, and finally when you calculate the x, finally when you will calculate the x, you have to add this x to every I comma j where it was present. So basically after calculating the x, you want to add the x at the every cell, not x. So how many multiples of x were there, right? So that is basically that dummy vector will store, and initializing dummy with the 0. And yes, so basically initially the sum of the each column and the each row be 0, and if string of 1 is down, so basically if it is going if the first step is downwards, then we want to check the row, right? So we want to check the row. So this sum is basically this value. Sum is basically this value, minus 14, not actually minus 14. So sum is basically this value 47. Okay, not minus 14. What was I doing? I don't know. So actually I know, but anyways, so x plus 47, so the sum will just be 47. Sum won't account for the multiples of x. So you will add this multiples of x after these constants are calculated, 3 minus 2 minus 4 plus 61. Okay, so after all these constants are calculated, you will add the multiples of x. Okay, makes sense. I think it clearly does. And yes, so calculating the sum based upon that, and initializing and tracing the path through the grid based upon the string. So I am initializing where we are with this position pair x comma y, and so by allocating the x, so by allocating dummy of 1 comma 1 as a 1, we have actually traced the one unit of the path. Okay, so basically if it is r, we have moved to the right, and if it is down, we have moved to the down. Okay, so we will start from index is equal to 2 to start our navigation. Okay, so while I don't make it to the last index of the last cell of the matrix, I will continue this while loop. And if my current step is towards the right, so remember, if my current step is towards the right, I want to calculate the sum based upon the uh, row, right? So row, so iterating over every row, I is equal to 1 to n, and calculating the sum just like we did here. So this temp will basically store these values 61, 50, 40. Okay, makes sense? Yes, it completely does. And temp 1 will store how many x were there in that row. Okay, so take a look at here. So if here, so here, right here, where I am highlighting this minus 3x plus 61, take a look at this. So when we were performing the right move here, we checked the sum of this whole column, right? We checked the sum of this whole column, and accordingly updated this dummy array as well, right? So dummy of position dot first and position dot second is equal to 1 minus temp 1. So why this 1 minus temp 1? So basically temp 1, so let us take a look at the example itself. So here in this case, my temp 1 was 1 2 3 4, right? My temp 1 was 4, isn't it? So I know that to maintain the sum of the column as x plus 47. Okay, and one more thing to notice is that, so when you start from the cell 1 comma 1, you will either go to right or either go to down direction. Okay, down. Okay, so when you go to the right and assign this value as x, take a look at this rightmost corner and uppermost corner of the screen. And yes, when I go right and make the cell 1 comma 1 as x, all the elements in the first column will be the constants, so my ultimate sum will be x sum plus some constant. So constant is basically the sum of these all values, right? So my multiple of x in the final sum is just the 1. Okay, whether I go to right or if I go down, take a look at the rightmost and the bottommost part of the screen. Okay, so if I go down, so basically I will take the sum of all these constants, right? So again, my ultimate sum will be x plus some constant. So in my ultimate sum, x is appearing only once, right? So that is why 1 minus temp 1, right? So notice here, so I am negating all the x which were present in the column. I am negating all the x which were present in the column, and finally I am adding one x to ensure the condition is met. Okay, I think that's the very well explanation for why this 1 minus temp 1 is there. And if step that is taken is towards the right, we want to increment the number of column by 1. So y, you can say y by 1, and same is the and similarly we will process the string one by one uh, for the down part as well. Basically the same code, just the iterating over what you can say, uh, row here for the down part and the column for the right part. Okay, and don't forget to increment the index in the while loop, otherwise you'll definitely run into the, what you can say, infinite loop. Okay, and one more thing to notice here is that when I make it to n comma m, my dummy, or what you can say, my matrix is not getting updated accordingly because I'm breaking the loop when I get to n comma m. And yes, for especially that, these two if and else conditions, they both do the same task only, uh, like the if else conditions in the while loop, I would say, right? Actually, there. Okay. Anyways, I could have made the condition not on the position but on the index to break the while loop. But anyways, it does the same task what we did in the while loop. And comes the most important part of the code. How long is code? Not so much from here. Okay, so LL, C1, C2, value 1 and value 2. Okay, so what these guys will be doing is that, okay, wait, this is not what I mean to open. So suppose this is my grid. Okay, not that big. Small thing will suffice. Okay, so the part starting from here is basically for calculating x. Okay, so suppose there were c1 x present in this column. Okay, there were c1x present in the column. Okay, and the constant value that was present in the column, let be it be val1. Okay, and for this row, let the number of x be c2 and the sum of the constants be the, what you can say, val2. And now I want to satisfy that both the sums are equal, right? So basically c1 times x plus, so I think I should increase the thickness a little bit. Yes. Okay, so c1 times x plus val1 should be equal to c2 times x plus val2. Okay, so here my x is basically val2. Okay, let me check what have I done in the code. So val2 minus val1. Yes, I will convert it in the same way as done in the code. Val2 minus val1 divided by uh c1 minus c2. Okay, makes sense. Yes, it absolutely does. And when will this edge case happen? When will this edge case happen is that, so basically it will happen if c1 is equal to c2, right? So notice here, so c2 here is 1 and c1 here is also 1, and when calculating x, c1 minus c2 will be 0 and it will cause division by 0 error. Division by 0 error. Will it? Yes, it definitely will. So if C1 is equal to C2, we need to handle this case differently. And if C1 is equal to C2, we don't have to do anything. You just, what you can say, you just output the matrix as it is without, what you can say, so you can say you have to directly output the matrix without even processing it with the dummy matrix. Okay, so yes, pretty long video. It has been an hour, but anyways, uh, yes, if C1 is equal to C2, okay, this LL sum was just basically the funny version of the sum. Okay, so that didn't quite help me with the anything. So you can basically ignore this part of the code. Okay, this part of the code. Yep, and just outputting the matrix as it is. Otherwise, calculating the x, and for every I comma j, just matrix of I comma j plus is equal to dummy of I comma j star x. Okay, makes sense. Yes, it completely does. And okay, so okay, again, this part also, ignore this part. It was good for nothing, as the after performing this operations, dummy of I comma j into x, uh, our matrix will be ready to output, and this basically calculates the sum, which is the sum of every column and every row, you would say, and this calculates the sum of the last column, which will basically be equal to the sum or sum, and makes then it will result in the operation which is adding 0 to this matrix of n comma m, which won't make any difference. And yes, so try to ignore these parts of code. Okay, this part, okay, this part and this part. Okay, and yep, so after ignoring the parts, our matrix is ready to output, and we will finally output the matrix. Okay, so I gave it a really good thought to solve this problem. Actually, there may be a simple idea in the editorial. I need to check it. Okay, and yes, I hope you enjoyed attending the contest and solving the problems, and yes, listening to this post contest discussion as well. I really appreciate your patience if you have made it till here. Okay, so yes, uh, if this post contest discussion helped you, uh, consider liking the video and staying subscribed, staying tuned to the channel. And yes, see you again, definitely. Oh, okay, wait, let us cross check if this works. Okay, what works? So ignoring the parts. Okay, is it making any difference? I think it is not. Let's check. Ideally it should not. Okay, okay, I think it mostly won't. Yes, it didn't. Okay, accepted. Not happy new year, huh? Okay, happy new year, happy new year again to all of you. Okay, see you again, bye bye.